Welcome to this explainer. Today, we're tracing the monumental evolution of computing and data storage. Have you ever actually stopped to wonder just how terrible our human brains are at holding vast amounts of raw, structured data? We're incredible at creativity and lateral thinking, but we are fundamentally flawed when it comes to rote memory. So we're going on a really fascinating journey today, moving all the way from 300 BC to the invisible realm of the cloud. It's essentially the story of how humanity has constantly strived to overcome our own mental limitations by building external systems that can remember, store, and calculate for us.
Okay, let's dive right in by startling you with a pretty crazy fact. The original computers weren't machines at all. Historically, the word computer was actually a job title. It described a human being, typically a highly intelligent woman whose primary occupation was to perform incredibly tedious and repetitive manual calculations. A perfect historical example of this is the famous group known as the Harvard computers in the late 1800s. These were brilliant women tasked with analyzing thousands of photographic glass plates to mathematically map out the stars. Whether it was crunching the numbers for complex navigational tables, tide charts, or planetary positions for astronomical almanacs, it was all done completely by hand, using raw, unfiltered human brainpower.
To keep this 2,000-year journey from feeling overwhelming, here's our roadmap. We'll start with Part 1, when humans were computers. Then explore Part 2, the mechanical age of math, followed by Part 3, the birth of the punch card. From there, we hit Part 4, the digital storage boom, and finally journey into Part 5, to cloud and beyond.
Let's kick things off with Section 1, when humans were computers. Here, we'll look at the very relatable human limitations that drove us to invent computational technology in the first place.
Picture the atmosphere of a typical computational operation back in the 18th or 19th century. Vast rooms full of human computers were absolutely necessary to process the world's data. Try to vividly imagine what it sounded and felt like inside one of these massive offices. You'd hear the relentless scratching of hundreds of pencils on paper, feel the stifling heat of a crowded, unventilated room, and experience the deafening silence of intense, concentrated mental labor. If an industry needed to keep written records, calculate taxes, or draft complex mathematical tables, they essentially had to mobilize an entire army of people to perform group manual calculations.
But here's the rub. Humans are fundamentally terrible at continuous, error-free repetition. Doing the exact same calculation for hours on end is profoundly boring, which inevitably leads to fatigue, carelessness, and devastating inaccuracy. And this really matters. Think about the high stakes involved here. A single misplaced decimal point in a manually calculated maritime navigational table could easily result in a ship drifting off course and wrecking against a reef. On top of those fatal errors, we suffer from short-term memory loss, our manual work is incredibly time-consuming, and housing these massive teams requires huge amounts of physical space. Humanity desperately needed a more reliable solution.
Which neatly brings us to Section 2, the mechanical age of math, where we start solving the calculation problem by transitioning away from human brains and toward physical mechanics.
To eliminate those innate, high-stakes human errors, the Babylonians actually gave us the abacus all the way back around 300 BC. Think of the abacus like the world's first external hard drive for short-term memory. It's like using your fingers to count, but on a massive, highly efficient scale. By sliding wooden beads along metal rods, a person could perform rapid addition and subtraction without having to hold all those carrying numbers in their head. The abacus brilliantly offloaded the short-term memory requirements of mathematics into a tangible, physical device that wouldn't just forget its state if the user got momentarily distracted. Fast forward past the ancient world, and the 17th century kicked off an absolute arms race of intellect. Over a highly concentrated 25-year sprint, we saw a rapid, exciting succession of physical calculating devices. In 1617, John Napier invented logarithms to simplify complex multiplication, and he carved these specific values onto sticks known as Napier's bones. Shortly after, in 1623, Wilhelm Schickard built the first true gear-driven calculating clock, and by 1642, Blaise Pascal invented the Pascaline, a highly complex gear-driven addition machine. This timeline really showcases an era where brilliant minds were utterly determined to mechanize the rigid laws of mathematics.
Now, what's super interesting here is the visual contrast between these early computational leaps. On one hand, you have Napier's bones, which are literally tactile, carved ivory sticks, functioning as physical alternatives to written logarithmic tables. And on the other, you have Pascal's Pascaline, an intricately designed, gear-driven brass box full of fluted drums and dials. As tactile and clunky as these brass and wood machines might appear to us now, they are the direct conceptual ancestors of the microscopic silicon chips currently sitting inside your smartphone. We were building the fundamental architecture of processing, just with cogs instead of electrical currents.
But calculating was only half the battle. To build a truly automated system, we needed a way to actually store instructions. Which leads us into Section 3, the birth of the punch card. In 1801, a French man named Joseph-Marie Jacquard invented a revolutionary power loom. But what changed the world wasn't the weaving itself, it was how the loom was commanded. Jacquard used stiff paper cards with punched holes to direct the operation of the machine, allowing it to mechanically weave incredibly intricate textile patterns without human intervention. This technology was actually so disruptive and threatening to manual weavers at the time that they actively sabotaged the looms, sparking some of the earliest Luddite labor riots in history. The automation age had officially begun.
Please take a second to appreciate what Jacquard's invention actually meant for the future of humanity. Each hole punched in that stiff paper card represented a simple binary digit. To break that down, a punched hole meant yes or a 1, and a solid space with no hole meant no or 0. It was, quite literally, the world's first physical software code. This marks the exact moment in history we realized complex data could be encoded mechanically into physical binary systems, establishing the absolute foundation of all modern digital data storage.
The English mathematician Charles Babbage later adapted this brilliant punch card concept for his proposed steam-driven computer known as the analytic engine. He divided his machine into two distinct conceptual parts, the store and the mill. The store was where numbers were held for future use, using physical punch cards. The mill was where those numbers were actively processed to give new results. What is mind-blowing about this is that Babbage's machine was designed to be the size of a Victorian house and powered by a massive steam engine, yet it possessed the exact same logical architecture as a modern iPhone, completely separating long-term storage from the active processor.
As we moved into the 20th century, computers finally went electronic. That brings us to Section 4, the digital storage boom, where everything becomes about speed, space, and scale. Because our data generation began to grow exponentially, our storage media had to rapidly evolve to keep up. We started with massive mainframes relying on bulky magnetic tapes and disks. Get this. To give you a sense of scale, back in 1956, an IBM 5-megabyte hard drive weighed over a ton. It literally had to be moved around a warehouse with a forklift. Over time, we shrunk that technology down into consumer hard disk drives. From there, we evolved to solid-state drives. And eventually, as businesses grew, we centralized our data using network-attached storage, or NAS. Think of NAS as a highly secure personal mini-cloud sitting right inside your own office building, effortlessly distributing files to everyone on the local network.
A pivotal breakthrough in this era was the invention of solid-state drives. See, traditional hard disk drives rely on a physical mechanical arm delicately scratching a magnetically coated spinning metal disk, very much like a needle on a classic vinyl record player. SSDs threw all that mechanical movement out the window. By replacing physical spinning disks with flash memory chips, SSDs store data by trapping electrons in microscopic grids. This completely eliminated physical moving parts from local storage, resulting in lower power consumption, much greater durability against drops and bumps, and it made accessing our data practically instantaneous.
This incredible history leads us directly to our final era. Let's explore Section 5, to cloud and beyond, stepping into the invisible realm. The advent of cloud computing heralded a massive paradigm shift. Instead of storing our precious files on fragile devices in our pockets or bulky servers in our closets, we pushed everything to the internet. To simplify what virtualized infrastructure actually means, instead of buying our own expensive physical hardware boxes, we're now just renting tiny, flexible slices of massive supercomputers owned by companies like Amazon or Google. For the end user, cloud computing completely eliminates the headache of maintaining on-premises hardware, offering unprecedented scalability and the glorious illusion of infinite, invisible storage capacity. Moving to the cloud also fundamentally revolutionized how we organize information, giving rise to object storage. Think of a traditional file system, like putting a single paper document into a specific nested folder inside a specific physical drawer in a giant filing cabinet. Object storage is entirely different. It's like tossing that document into a massive unstructured pile, but attaching a highly advanced GPS tracker and a deeply descriptive tag to it. That descriptive tag is called metadata. Because of this rich metadata, the system can instantly summon the exact object you need in milliseconds, no matter where it physically lives across millions of distributed servers globally.
So we have traveled from human beings desperately calculating maritime charts by hand, to sliding wooden beads on rods, to punching holes in paper cards. And now, we pull infinite streams of data from an invisible global cloud. So what exactly does the future hold? Well, scientists today are actively exploring quantum storage to save data at the subatomic level. They're successfully mapping vast archives onto synthetic biological DNA molecules, and even using three-dimensional holographic light to preserve data for thousands of years without degradation. I leave you to imagine these mind-bending possibilities. Where will our unending quest to outsource the human mind take us next? Thank you so much for joining this explainer, and keep learning.